if you choose a personality that ends in the words with hot water heat, then it'll use output 3 to open a floating valve actuator and output 4 to close, floating or tri-state. Some people use one term or the other. And so then we have to enter the hot water valve base time in seconds, which is the drive time of the actuator to go from fully closed to fully open and vice versa. And on reset, we're going to drive the valve closed for the full base time to make sure we start from a fully closed position. And then the hot water valve position set point will be the calculated position in seconds. The hot water valve actual will be where we think the valve currently is in terms of seconds. And so it's going to turn on the open output 3 if the actual position is less than the desired set point. And then it will close the valve if the actual position is higher than the desired set point. So I'll make that change now. So I'll go to the Configure tab. I'll click on the personality, and I'll choose VAV with hot water heat. Click OK, and yes. Okay, so now it's running on the new personality 5. Gonna recheck the tables. Now if I switch to the heating tab, I'll see that the hot water valve actual is driving closed for the base time. And then once it thinks it's fully closed, then it will start opening up to meet the set point. I see a little overlap on my screen. I thought they had fixed that. On your screen, do you see the hot water valve status overlapping with the hot water reset enable or not?
No, ours looks good.
Okay, so all right. I'm gonna fix mine. When I install the software, if my screen was more recently edited, sometimes it doesn't update. So I'm gonna fix. You don't normally need to do this, but there's this edit layout button where you can actually change what's on the screen or move things. I'm just gonna move this guy up there and there. So yours looks like that without the overlap.
Yes.
Okay, good. So mine's driving closed. My heating requirement 7.5%. So actually, I think on the status tab, we can see the same things here. So now if I take the 120-second base time and multiply it times 7%, then we should want to be 9 seconds open. 9 out of 120. Looks like it might update just one more time too. So there's 11.4 seconds, 120 times 0.114. So we'll open for about, there's the 13 seconds. So it opens for 13 seconds, actual incrementing each second. And once it reaches 13, then it stops. And then at the next 30-second mark, the heating requirement will increase. Maybe it'll be 17 seconds, and then it'll open 4 more seconds if it needs to go from 13 to 17 seconds. So 120 times 0.145, that happened to be 17 seconds. So notice it just opens to make the difference between where it was and where it wants to be. And so once it gets to 100%, it won't drive open indefinitely. It'll just try to open to what position it wants to be in, and then it will stop there. And then what it will do every time it goes into deadband, it will drive closed for an additional base time to make sure that it is fully closed. If you've worked with tri-state or floating equipment before, you might have seen that you can lose fractions of a second as you change directions back and forth. So it's good to kind of reset the 0 position so that the controller and the actual field device are in sync. So that's how, if you had a floating hot water valve actuator. If you had a modulating valve actuator with using an analog output, I mentioned that the analog outputs operate independently of the personalities. So you don't even need to choose the with hot water heat option personality if you're using the analog output. And in fact, that would free up outputs 3 and 4 for other purposes if you needed them. But there's an analog output tab where there's an analog output 1 assignment that's almost always linked to the heating requirement. And then you can put in your min max voltage to match the range of your valve actuator. 0 to 10 or 2 to 10 are probably the 2 most common ranges. And so to see that, you can go to other views, and analog output's about halfway down here on the left. And then here's the AO1 assignment. If you click on that AO1 assignment, you'll see these choices. Heating requirements almost always what you're going to choose if you're using an analog output. So click OK. And then here's the min voltage, max voltage. It defaults to 9.96. You certainly can go as high as 10. And so 0 to 10 is one range you might choose, 2 to 10 is another. So anything within a 0 to 10 volt range you can use there. And so if you did the math here, the heating requirement's 33%. So 33% of 2 to 10 would be 4.7 volts. If you were to measure the analog output voltage with a meter from common to AL1, you should see about 4.7 volts. And by the way, when measuring the triac outputs, if you're using a meter to see if a triac output is on, you do need to have some sort of load on the output, or else you can't use a meter to accurately determine if the output is on. So that load could be, it could be an actuator, it could be a relay, it could be something like a 24-volt LED, but you do need to have some kind of load, or else you can't use a meter to accurately determine if the triac is on. And what I usually do to see if it's on is I measure AC voltage between the triac output and 24-volt hot. And if I see 24 volts, then that means the triac output's on. If I don't see 24 volts, that means the triac output is off. So that's the hot water valve actuator for modulating. For the fan-powered personalities, there's a fan tab, and then I copied this table from the application bulletin. And so for intermittent fan personalities, there's this fan energized airflow set point, which is in CFM. And if the measured airflow is less than the fan energized airflow set point, then anywhere where it says fan on with the asterisk, then the fan will be on. So anytime it's occupied, the fan will be on. And then if it's not occupied, the fan only turns on in a low airflow condition while in the heating mode. So we can see that by going to the configure tab. And I'm just choosing intermittent fan cooling only. The reheat options are the same for the fan powered boxes as they are for the VAV in terms of how the heat turns on, how the hot water heat valve positions, all that sort of thing. So intermittent fan cooling only, click OK. Yes, I want to reset the device. And so there's a fan tab that automatically shows as part of that script running in the background for fan powered personalities. So my measured airflow is 0, and which is much lower than the fan energized airflow set point, and the fan is on because I'm occupied. So on the status tab here, I see that the fan is on because I'm occupied. If I want to see the fan turn off, then I could go into the unoccupied or night setback states as long as I'm not in the heating mode. And so you can actually override the state temporarily from ASI Expert on the status tab. there's this button for state OR action. And if you click on it, then it gives you the option to override to any of the states. So I'll just choose night setback. It's at the top of the list. I click OK. This state overridden changes from no to yes, meaning it's been overridden to the night setback state. And then the fan status is on because I'm in the heating mode, but once my heating requirement goes to 0 and I'm 1 degree satisfied, then I'll go into deadband and the fan should turn off. And so there's night setback and deadband, and there's fan status off. And if you wanted to see that table in the documentation, if you went to the help menu in ASI Expert, you can go to ASIC 1, 6100, APB is the application bulletin for the 6100 controller. On the contents tab, if you click on the plus next to intermittent fan VAV, click on the plus next to outputs, click on the plus next to intermittent fan, and there's a section on intermittent fan control, and this is the table that I copied and pasted into the slide. If you just go to the intermittent fan level, it kind of gives you a text description about what it's doing. Constant fan is a little different. It still looks at state and mode, but it doesn't care about that fan energized airflow set point. So it just, the fan's always on in heating. The fan is off in deadband except for occupied and morning warm up. And then there's actually a choice for cooling. Usually I think you don't want the fan to run except in the heating mode. So by default, the fan will be off in cooling when not occupied or morning warm up. But if there is a case where you need it, there's a couple of checkboxes you can set for unoccupied and NSB. So if I go back to the configure tab and I change the personality to constant fan cooling only. And yes, I want to reset the device. And so on the status tab now, whenever you reset the controller, it always starts out in occupied and deadband. And so just being occupied means the fan is on, right, according to the table. So I'm right here now, on and occupied. So to see the fan turn off, again, I could go to either unoccupied or night setback. And I can click on the status tab. There's a state OR action button. This time I'll go to unoccupied just to be something different. Click OK. The active control state goes to unoccupied. The state is overridden yes. I'm in the heating mode, and then, but at the next 30-second mark, I should go into deadband, and then the fan should turn. So there's deadband, there's off. Okay. Wall sensors. There's a wall sensors tab that gives us a few choices. There's a user adjust enable checkbox that says, can I adjust the set point from the wall sensor? There's an after hour enable checkbox that says, can I request a temporary period of occupancy from the wall sensor? If you do set user adjust with a digital wall sensor, then there's limits that you can change here to limit the range of set point adjustment from the wall sensor. And for after hours, the after hour time allowed is in minutes. With a digital wall sensor, there's also this checkbox for single set point enable. And we have independent heating and cooling set points. So our initial release of the digital wall sensor, we allowed or actually required the user to set the heating and cooling set points independently. And so you would press the mode button to go into set point adjustment, And then the default, it started out adjusting the cooling set point, and then you could toggle between cooling and heating set points with the power button. And so what would happen is people would be cold, and then they would go into set point adjustment mode, which is the correct starting point. But then they would just raise the cooling set point and wonder why the heat didn't turn on. And it's because they didn't raise the heating set point. But that became a little problematic. So we, in terms of, kind of teaching end users to toggle between two set points. So then we added this single set point enable mode. And what it does is you don't even have to press the mode button anymore to get into set point adjustment mode. You can immediately press the up down arrows. And then what it will show you is the average of the heating and the cooling set points. And since they're usually 2 degrees apart, it's 1 degree lower than the cooling set point and 1 degree higher than the heating set point. Then they can use the up down arrows to just shift that midpoint, and then it adjusts the cooling and the heating set point at the same time. And so that ended up saving a lot of service calls, and that's easier for a lot of people to work with, as opposed to changing the heating and cooling set points independently. So that's what this single set point enable checkbox does. And so if you want to see that, you can go to other views and wall sensor. And so here's user adjust enable. You do also need to set digital display enable to yes when using the digital WSO61 wall sensor, because that tells the controller that it should try to communicate with that device, because there's, as part of that 8-wire connection, 2 of those wires are actually communicating for communication between the controller and the wall sensor. So when using a WSO61, you have to set that jumper that I showed you on the board itself to supply power, and then you need to set digital display enable to yes in software so that the controller knows to communicate with the wall sensor. And so when single set point enable is yes, then the range of adjustability is actually determined by the cooling temp upper and lower limit. So let me go back to occupied. I'll do status, state OR action, set state to occupied. Back to my wall sensor tab. So the occupied set points are cooling 72 and heating 70. So if I were able to touch my wall sensor now, press the up down buttons, and I can't because I'm remote, just like you guys. But if you were to press the up down buttons, then it would show you 71, and it would let that midpoint go as high as 84, because that would be cooling 85, heating 83, and it would let that midpoint go down as low as 70, because that would be cooling 71, heating 69. So that's a pretty broad range, and you may want to tighten that up by adjusting the cooling temp upper and lower limit. For after hours enabling, we can actually simulate that. There's this as if pushed action. So if I want to see what would happen when somebody pushed the button, I first want to get out of the occupied state. So I'll go back to my status tab, and I'll go to my state OR action, and I'll go to night setback this time. You can get the temporary period of occupancy either from night setback or unoccupied. So now that I'm in night setback, if I go back to my wall sensor tab, this as if pushed action would cause the controller to behave the same as if somebody actually pressed the power button on the WSO61, which is used to initiate an override. So I can see here, once I use the as if pushed action, the active control state went to occupied, the after hours request and status went to yes, and the after hour time remaining went to 60. So every minute it's going to count down by 1 in the after hour time remaining field. And then when it counts down to 0, then it will go back to its whatever state it had been in, I think was night setback. ASIC 1 trends. There's a trends tab where you can enter, you can log up to 2 values. You need to enter the table and entry So you need to know where that piece of information is stored in the controller, and I'll show you a little shortcut that helps you find that information. And then we keep track of the last 96 entries. So at a 15-minute interval, that would be 24 hours worth of information. So we can keep track of nearly anything in the controller in the trend log. And one thing I usually do as an example is like the active cooling or heating set points. So one way to know where it's stored, because the values are stored in tables and entries, so different values are stored in different tables, and then within each table there's different entries. So if you hold the shift button down on your keyboard while you right click on any value, it'll pop up this little screen. And then you can actually release the shift button while still holding the right mouse button down. So the active heating temperature set point is table 10, entry 24 is its storage location. So I'll just type this in here just so that I can remember it. So active heating temp SP equals table 10, entry 24. And so then if I were to go other views and trends, then I used to be able to click on this trend name field. Somehow they took that functionality out. But if I know the table and entry, I can enter it here. So table 10 is already there, that's correct. But if I change the entry number, I can just click on the table 1 entry, trend 1 entry number and enter 24. It will look it up in the database and say, okay, that's the active heating temp SP. And again, you can log up to 2 values. Maybe I want to check the occupied set point. So on the configure tab, if I did shift right click on maybe the cooling off temp SP, that's table 2 entry 1. I'll type that in here. Cooling off temp SP equals table 2 entry 1. And if I go back to my trends tab, for the second trend point, trend 2 would be table 2, and the trend 2 entry would be entry 1, and it says, oh, that's the cooling off temp SP. And then the first time you set it up, the trend interval can be in 15-minute intervals. It could be 15, 30, 60 minutes, but it needs to be in a multiple of 15 minutes. The 15-minute interval is the quickest. It can trend the most frequent trend interval. And then you do need to click this Start Trend button. It'll mark a couple of these entries with this yellow background. The yellow background means that the software is aware that a change needs to be sent to the controller, but has not yet been sent. And so this Send button up above the tabs had gray text, which means disabled, can't click me. But once I click the Start Trend button and these got marked in yellow, then the Send text changed to black, which means you can click to push those changes down into the controller. And then it pushes those down and the yellow background goes away. And so then at 10 o'clock, which is the next even 15-minute interval, it'll log the first value. And then once you have logged some values, then you can click this Display ASIC 1 Trend button, and it'll upload the information and show it to you in a graph. I don't have any good information yet, but and you can toggle between Trend A for Trend 1 and Trend B for Trend 2. So this is some old trend data. I think that's not relevant. That's how you can view it once you have collected the trend data. Lighting schedule. I don't think it's frequently used, but there is a lighting tab. So you do need to have an unused output, and that you need to assign it. We call it a mask. And then it can follow separate schedules with 2 on times and 2 off times in 15-minute increments, where 12:15 a.m. is the first valid time, just like the state schedule. You could choose to just to disable the internal schedule. You can also choose to just follow the occupied signal. So whenever occupied, the light should be on. And then there's a checkbox for lights reverse enable, which means turn on the output to turn off the lights. And sometimes that's helpful, so that if the controller were ever to fail or power down, that the lights go on. So a lot of times you want the lights to fail to the on position. So if there was a problem with the controller and the output turned off, then perhaps you want the lights on. And so let's take a look at that. Other views, there's lighting is kind of down towards the lower left corner of the other views tab. And so the lights on off map default to none. If you're not sure which outputs are available, there's this output summary tab. And usually if it's grayed out, that means it's not being used. So if I was looking at this, I would think that outputs 1, 2, and 5 are in use, which means if I needed to assign the lighting function somewhere, I could assign it to outputs 3 or 4. So I could even change the lights on off mask right from this output summary tab. So I'll put output 4 in there. When you do change the mask, you do need to reset the controller. So that reset ASIC button is like a soft reset. So now if I go to the lighting tab, so the lights output is on because it thinks it's Monday at 9:49, which is between the on and the off times. There's also this blink timer, and it's described on the slide. So at the off time, we blink the lights, we turn them off for 1 second and turn them back on, and then count a 60-second timer that after that 60 minutes passes, then we'll turn the lights off indefinitely until the next on time. And that's just sort of a warning in case there's not good emergency lighting. The blink is intended to say, hey, the light's going to get dark in a minute. So either go push the override button if you have lights occupied enable, or leave the building if you don't want to get stuck in the dark. And so it's really meant for interior lighting. Exterior lighting, you wouldn't want the blinking of the lights to occur.